Happy to be with you. Welcome back to the session. So in this video lecture, I am going to explain about the conducting polymers. So till here we have learned about various types of polymers as I have given in the introduction class. A brush, a plastic mug, bottle, right? Velvet bottle, then cable wires, etc. like that. We know many types of polymers. The basic common property of a polymer is they are very good insulators, right? So that's why they are going to be covered to the electric wires, that copper wires, so that it prevents from the electric shock. But how a polymer can be a conducting one? Is there any chance that polymer can conduct electricity? Just think, pause this video, think, and then tell me your note down your answers on the paper. So check whether they are going to coincide with my answers or not. Right? So the main difference for a polymer, whether to be an insulator or conductor, is in insulator there is no availability of free electrons. So hence it is a insulator. So in the polymer backbone or by addition, whatever it may be, in a polymer, if you are going to create some or exist some free electrons, then such polymer is conducting. So hence they are called as conducting polymers. Okay? So this is the difference between an insulator and a conductor, obviously. The same thing is applicable for polymers also. So a polymer that conducts electricity. So what are the various types of conducting polymers, right? So if you see, usually there are two types, intrinsic and extrinsic. So intrinsically conducting polymer, so which is nothing but the conductance. Conducting polymer is nothing but which is capable of conducting electricity. Then you can say it as a conductance. So conductance is due to extensive conjugation in the backbone. Right? So this is about intrinsically conducting polymer. The second one is extrinsically conducting polymer. So nothing but by using external reagents, the polymer starts get conducting. Right? So suppose coordination conducting polymers or inorganic polymers, whatever it may be, if you add some external reagent, so that it starts conducting. That is about extrinsically conducting polymers. So this can be shown with the help of a schematic representation, right? So conducting polymers intrinsically and extrinsically. This is secondary. We are not using that one to the greater extent, right? That is coordination or inorganic. So the main thing is intrinsically nothing but, as I said you, within the polymer backbone itself. So conducting polymers having conjugated pi electrons in backbone. So here in this case, doped conducting polymers. So in cases, apart from having in their original backbone structure, we are going to add external reagents, external impurities. That process is called as doping. So this is of two types, p doping and n doping. This is all about intrinsic. In case of extrinsic, two types, conductivity filled element, and the second one is blended conducting polymers. Now I will explain one by one. Intrinsically conducting polymers, right? If you see, simply I can explain by taking small example. Pyrrole is there, or will you call it as pyrrole? It's up to you pronunciation. So which it consists of two alternative double bonds. NH, of course, nitrogen also contains a lone pair of electrons. So what will happen in this conjugation? When you are going to participate in the resonance, obviously this shifting, this pi bond will shift here, obviously this will shift here, nitrogen gets positive charge, again this shift. So like this, the shifting of electrons will take place. So whenever this electron shifting is there, obviously there exists the presence of electrons. So So simply you can say availability of electrons are responsible to conduct electricity. So all these exist in the polymer backbone. Obviously it is called as intrinsically conducting polymer, right? So instead of this polypyrrole, you can take acetylene, very good example, right? Alternative, that CH triple bond, CH, like that triple bond will be there. So in that you can convert trans or this polyacetylene because of this alternative existence of double bond. Because after polymerization, triple bond will be converted into the double bond. If it is double bond, it will be converted into the single bond. If it is single bond, it does not participate in the polymer and it does not suit for the polymer, right? So this is about the scenario. So hence, a polymer backbone, either it must consist of either a double bond or a triple bond. It means unsaturation is one of the major criteria for a polymer, right? So upon polymerization, if it is double bond, will be converted into single bond. If it is triple bond, will be converted into the double bond. So with this shifting, the availability of electrons will take place. So hence simply you can say such polymers are capable of conducting electricity. If all in this case polyacetylene, pyrrole, pyridine, etc. So the whole electrons are going to exist. So they are examples of intrinsic conducting polymers, right? So in this intrinsic, again we have about doped. So doping nothing but adding of foreign impurity in order to improve the conduction properties. So this is P doping. So P is nothing but you are supposed to create a positive charge on polymer backbone. That is called as P doping. So it is done by oxidation process. The conducting polymer is treated with the Lewis acid. So this is the suppose you take this polyacetylene. So as I said, acetylene is a very good conductor because here in this case the triple bond upon polymerization will be converted into double bonds. The shifting will take place. The electrons are responsible to conduct electricity. So for this again, if you add a Lewis acid, so that it creates a positive charge on polymer backbone, then it is called as P doping. So similarly, if you create a negative charge on polymer backbone, then this is called as N doping. So this is the polymer. If you add Lewis base, then obviously it is going to convert into the right. So Lewis base, so that we are going to get the N type of doped conducting polymer, right? So what are the advantages? So they have conductivity, they have storage and charge, ability to undergo ion exchange, right? And they can absorb visible light to give color compounds, and they are transferred to X-rays, right? So extrinsic conducting polymers are not included in your syllabus, but little bit I will explain you. Please listen. I have not included the slide, but still I will explain little bit. So extrinsic conducting. Extrinsic means by adding external reagents. So what are the two types present in this? Right? This will I will show you the slide. So in case of extrinsic conductivity field element. So here for the non-conducting polymer, we have to fill a conductivity element. The conductivity element is carbon black. Why you have to choose carbon black? Because of two reasons. Listen very carefully. So it has large surface area and high porosity. Hence we have to choose the conductivity element filled polymer. The second one is blended. So with this what will happen actually? So because of this carbon black addition, right? Minimum quantity can be added so that the other polymer also starts get conducting. Simply you know the preparation of curd, right? To the warm milk, lukewarm milk, you are going to add a small amount of curd so that the whole milk will be converted into the curd. Like this, minimum quantity of this carbon black will be added to the non-conductive so that a whole polymer starts get conducting. So that is called as conductive element filled polymer. The second one is blended. Blender. What is meant by blender? As you know, the preparation of desserts like ice creams, cakes, etc., etc. So you are going to use a blender. It means which mix the contents very much thoroughly. So that is about blender. So here we are supposed to mix the 40% of the polypyrrole with that of the non-conducting polymer so that the whole will become conducting polymer. So why should you choose pyrrole? As I have explained in case of intrinsic. Apart from alternative double bonds, nitrogen have lone pair of electrons. So they also participate in the resonating structures. So hence enhancively it increases the conducting properties. So that is about the blended conductive polymers. These are about external, these are about the internal. Now let us see the applications. Yes, can anyone explain about the applications? So these are the various applications. Can be used in rechargeable batteries, analytical sensors, ion exchangers, electromic displays, optical filters, electronics, photovoltaic devices, telecommunication systems, anti-static coatings for clothing, solar cells, molecular weights and switches. So if you take even one subcategory also, whatever it may be, so it plays major important role. Hence, conductive polymers are very, very important and essential. So above all these things, it has wide range of engineering applications. So polymers are very important. So some of them are going to act as insulators. So some of them are going to act as conductors. Right? So thank you all. So we will meet you in the next video lecture. Thank you all once again. Bye bye.